Fine. Now typically this confidence intervals and hypothesis testing, the questions are largely around confidence intervals. Hypothesis testing is only checked conceptually. You don't really get big questions on hypothesis testing because it takes a lot of time to solve every one of those. It's not easy to solve those. Fine. So that's the broad parameter around this. Fine. So what do we mean by a large sample? Anything greater than 30 is large. Anything greater than 30 is considered large. If it is less than 30, you start using t-tests instead of z. Fine. So that's this confidence interval. When the population variance is not known and the sample size is not large, then we use something called t-distribution instead of the normal distribution. T-distribution is also symmetric and is defined by a single parameter called degrees of freedom. Now, for a sample with size n, the number of degrees of freedom is n minus 1. Fine. So when you solve for this, the values of t alpha by 2 will effectively also look at something called degrees of freedom, which you will find in the t table if you look at it in detail. Fine. So that's your confidence intervals. Let's quickly try and solve a question on confidence intervals as well. So let's look at this. A random sample of 400 consumers spends $100 on average at cinemas for food and beverages. Assume a normal distribution and assume a population standard deviation of 50 and calculate the 95% confidence interval for the mean spending on food and beverages. Fine. So I want to find out with a 95% confidence interval, what will be the average spend that anyone out of this sample of 400 people do. Fine. So I have the sample mean. I have the population standard deviation given to me, which is sigma. I have n, which is sample size, which is 400. I will take the square root of n, which is 20. The standard error is given by sigma by root n. If you remember, standard error is nothing but sigma by root n. I solve for that here to get 2.5. Sigma is 50, root n is 20. Z value for 95%. How do we get Z value for 95%? So let's find out the Z value of 95%. So remember, 95% means 2.5 on one side and 2.5 on the other. So let's find 2.5 on one side. Sorry, give me a second. Let's find 2.5 on one side. So we want to search for 97.5, which is here. This is the value we are looking at, 97.5. So the Z value is 1.96. That's what is the Z value. If I was looking at a 90% confidence interval, then I would look at the value somewhere here, 95% on one side and 5% on the other side. So effectively I have to do plus minus Z values here, which is 1.65. Fine. So that's what we have calculated here. This is the Z value at 95%. This is the Z value at 90%. I am solving for both of these. Effectively, once we have calculated this, remember the estimate is given by x bar plus minus Z into alpha by 2 multiplied by sigma by root n. So x bar plus Z sigma by 2 sigma by root n will give me the upper bound, and minus will give me the lower bound, which means with a 95% confidence, we can say that it will lie between 95.1 and 104.9. Fine. So that's what your intervals would mean. If you want a 90% confidence, then you get these values effectively. Fine.